You think you're sitting on a chair right now. You can feel the pressure on your legs. You trust that sensation. But I'm here to tell you that physically you are hovering. You have never touched anything in your life, and you never will. The sensation of touch is actually a lie your brain tells you to hide a terrifying reality about the forces that actually rule the universe. We define our reality by solidity. If I kick a rock, it hurts. Therefore, the rock is solid. If I lean against a wall, it supports me. We navigate the world assuming that matter is stuff that takes up space, and that when two pieces of stuff meet, they crash into each other. But this intuition is based on a lie. It's a hallucination of scale. You only think things are solid because you are huge. If you could shrink down, way down, the universe would start to look very, very different. Stop. Look at the tip of your finger. It looks smooth, continuous, a barrier between you and the world. But let's zoom in, past the skin cells, past the molecules, down to the atoms. We need to talk about what an atom actually is, because the picture you have in your head, little balls orbiting a center like a solar system, is wrong. And not just a little wrong, it's misleading. Matter is mostly empty space. And when I say mostly, I mean effectively all of it. Let's use an analogy to get the scale right. Imagine we take a single atom from your fingertip and blow it up until it is the size of a professional football stadium. The nucleus, the protons and neutrons, where almost all the mass lives, sits right on the 50-yard line. How big is that nucleus in our stadium-sized atom? Is it a truck, a car? No, it is a marble, a tiny glass marble sitting in the center of the field. And the electrons? They are tiny gnats, buzzing around in the highest rows of the bleachers. Everything in between the marble and the gnats is nothing. Vacuum, empty void. Your body is made of these atoms. The chair is made of these atoms, which means you are 99.9999% empty space. So here is the obvious question. If I am empty space and the floor is empty space, why don't I fall through it? Why don't the two empty spaces just slide through each other? Why is there a collision? Why can you stand up? If you ask a normal person, they say, because it's hard. That's not an answer. That's just describing the sensation. If you ask a chemist, they might say electron repulsion. We're getting warmer. Here is what is actually happening. You know how magnets work. You take the north pole of one and the north pole of another. You try to push them together. You feel that? That invisible squishiness? You are pushing through empty air, but something is pushing back. You can't see it, but you accept it. You say, oh, that's magnetic force. Well, I have news for you. That sensation, that resistance in empty space is the exact same thing as touching a wall. Let's look at the edge of your atom again. Surrounding that tiny nucleus is a cloud of electrons. Electrons have a negative charge. The atoms in the table also have electron clouds with a negative charge. There is a fundamental rule in this universe. Like charges repel. When you lower your hand toward the table, the electrons in your skin are screaming at the electrons in the wood. They despise each other. They push back with a force that is staggering. The electromagnetic force is 1042 times stronger than gravity. That is a 1 with 42 zeros after it. Gravity is trying to pull your hand down, but the electromagnetic force of the electrons says no. So when you touch the table, you aren't touching it. Your electrons and the table's electrons never actually make contact. In fact, contact doesn't even exist at that scale. What you are doing is bringing your atoms close enough that the repulsive force field becomes strong enough to stop you. You are hovering on a cushion of electromagnetic force, about 8 meters thick. But wait, if it's just repulsion, why does it feel hard? Why doesn't it feel spongy, like the magnets? If I push hard enough on the magnets, I can force them to slip past each other. Why can't I force my hand through the table if I push hard enough? Because there is another rule, a deeper, weirder rule, called the Pauli exclusion principle. Matter isn't just forces, it's stubbornness. The Pauli exclusion principle states very simply that no two electrons can exist in the same state, at the same place, at the same time. They cannot occupy the same address in the universe. If you try to squeeze the atoms of your hand into the atoms of the table, you are trying to force electrons to occupy the same quantum state. Nature forbids this. To force them closer, you would have to give the electrons enough energy to jump to a higher state, an upper deck in that football stadium. That requires an enormous amount of energy. That resistance, that refusal of the electrons to share their seats, is what you call solidity. Solidity isn't a property of the material. It's the energy cost of trying to break quantum rules. So, if there is no touch, only fields pushing against fields, why does it feel like contact? Why do I feel the texture of wood or the cold of ice? Your brain is a survival machine, not a physics engine. It doesn't care about quantum mechanics. It cares about not falling off cliffs and not getting eaten. When that electromagnetic field pushes back on your finger, it compresses the nerve endings in your skin. Those nerves fire an electrical signal to your brain. Your brain receives that signal and translates it. It doesn't say alert, electromagnetic repulsion at 1008 meters detected. It says solid object, do not walk through. The sensation of touch is a user interface. It's an icon on your desktop. When you click the icon, it opens a program. But the icon isn't the program. Touch is just the icon for force field interaction. This realization should be disturbing. It means you are isolated. You are trapped inside your own force field, forever separated from the rest of the universe by a tiny, unbridgeable gap. You will never hold the hand of someone you love. You will only ever feel the repulsion of their electrons against yours. But there is a more beautiful way to look at it. If stuff is an illusion, then what are we? We are patterns. We are stable configurations of energy fields. The universe isn't a collection of billiard balls crashing into each other. It is a symphony of fields, gravity, electromagnetism, nuclear forces dancing with each other. When you sit in that chair, you aren't a thing sitting on a thing. You are a remarkably complex bundle of ancient energy floating effortlessly on a sea of forces that have existed since the Big Bang. The fact that you can't touch anything doesn't make reality less real. It makes it more miraculous. It means that the solidity you rely on is actually a dynamic, active, energetic refusal of the universe to collapse. You don't need solidity. You have forces. And frankly, hovering is much cooler. Next time you pick up a cup of coffee, remember, you aren't holding it. You are manipulating the fundamental fields of the universe to levitate that cup to your mouth. If you want to keep shattering your intuition and seeing the world as it really is, not the lies to children version you learned in school, click subscribe. And if you want that four forces cheat sheet to understand the hierarchy of reality we talked about, the link is right there in the description. Nature is strange. Let's keep looking at it. If you want to keep shattering your intuition and seeing the world as it really is, not the lies to children version you learned in school, click subscribe. If you want that four forces cheat sheet to understand the hierarchy of reality we talked about, the link is right there in the description.